Okay, 10.5 is angle relationships in circles. So in the last section we talked about what would happen when we have an inscribed angle like this. So the measure of that inscribed angle is going to be half the measure of the intercepted arc. So if this is x, this is 2x. So let's say this is 30 degrees, then the intercepted arc would have a measure of 60 degrees. Okay, that same kind of thing is going to, that same kind of relationship is going to hold true in this scenario. Okay, so this angle right here is not an inscribed angle because one of the rays is outside of the circle. But it's still, if we call this angle x, the measure of that angle x, the arc that it intercepts right here is going to be 2x. Okay? And we could do the same thing on the other side. So if I call this y, then this arc out here is going to be 2y. So it's really the same kind of situation. It's just that one of the rays is outside of the circle. Okay. All right, so that brings us to the angles inside the circle theorem. All right, so when two chords of a circle intersect, the angle that they form is equal to the average of the two intercepted arcs. I wanted to put the word "the" in. There it is. The average of the two intercepted arcs. Okay, now that's a lot to digest there. So it's going to be easier to explain this in picture format and with this diagram here. Okay, so we've got two chords that meet inside a circle. Okay, so that's our scenario there. When two chords of a circle intersect, they're intersecting. They may or may not intersect in the center of the circle. They don't have to. So I wanted to show that this scenario could be true. Okay, so let's say that now there are four different angles that are formed. So I could use any one of those four angles in there with this theorem. But let's say I'm looking for this angle. Okay, so the two arcs that are intercepted there. Well, if I've got this angle, then arc AB over here would be intercepted. Okay, but since those lines are extending out the other way, I could also say that CD would be an intercepted arc. Another way you can think of that is that if this angle is x, this angle is x as well because those are vertical angles, right? When two lines intersect, the opposite angles are congruent. Okay, so these are the two intercepted arcs that I was talking about up here. Okay, so that means in this scenario that the angle that's formed, which here's x, is going to be the average of the two intercepted arcs. So the way I would find the average of two things is to add them together and divide by 2, right? Or take, so you can write this in two different ways. So I could take the measure of arc AB plus the measure of arc CD and then divide it by 2. And that's actually the same thing. If you're dividing by 2, that's the same as multiplying by 1/2. I don't know why, but for these types of problems, I like to do the 1/2 times, but you can divide it by 2. Makes no difference. Okay. All right, so let's try using this relationship in an example. So we're going to solve for x and y here, okay? On this next problem, I'm going to put some given info in here, and I'll do that in black pen so you can tell what the given info was. Okay, so let's say I know the measure of those two arcs. Okay, so I'm thinking, oh, okay, if this one's x, this is x. And then if I look at the two arcs that those angles are intercepting, that would be this one and this one. And those happen to be the two that I know the measure of. So now I can say that x is going to be the average of those two blue arcs. Okay, so x is going to equal 1/2 of 130 plus 156. Okay, and then so that's 1/2 of 286. And that's going to come out to 143, and this is the measure of an angle, right? So I want to show that x is 143 degrees. Okay. All right, I'll give you one to try. Let me put the given info in here. Oh, what am I talking about? I didn't solve for y yet. So with y, the intercepted arcs, I could say that this is y right here, and then that arc and that arc would be intercepted. The problem is I don't know the measures of those arcs, okay? I could actually find, because the whole circle is 360, I know what the sum of those two would be. So you could do it that way, but honestly what I would do here, we've got x and y form a linear pair. So they're going to be supplementary. So once I have one of them, it's pretty easy to find the other one. So y is going to be 180 minus 43. And that's going to come out to 37 degrees. Oh, almost forgot about y. Classic. Okay. All right, so same thing here. I can see that's going to happen on this next problem. We got a linear pair there. Okay, so the rest of the given info here, this is 80 degrees, and this is going to be y. And I messed up the directions. We're going to solve for x and y. Okay, so why don't you give that one a shot? You can pause the video, and I'm going to work through it now. Okay. So, yeah, I can find x very quickly without this new theorem at all, because I know x and 94 form a straight line, so they're a linear pair, and that means they are supplementary. So I just have to subtract 94 from both sides, and I'm going to get 86 degrees for x. Okay, so let me put that in the picture. Okay, now notice that it kind of looks like that might be a central angle, but notice I've got 86 degrees and 80 degrees. So it's definitely not a central angle. So this must not be the center of the circle. It looks like it's actually a little bit below the center. But just because something looks like the center, don't assume it's the center unless it looks like the center and there's a big dot there. That's supposed to indicate that it's the center. And then the measure of the central angle would be the same as the arc that it intercepts. Okay, so in this scenario, now I've got the 86. So I can say, well, the 86 is going to intercept this arc. And then if you go to the reverse side, I know this would be 86 down here as well, because those are our vertical angles. So the 86 degrees is going to intercept the 80 degree arc and the arc that's y degrees. Okay, so the angle is going to be the average of the two intercepted arcs. Okay, so the angle here is 86, and the two arcs are y and 80 degrees. So I'm going to do half of the sum of those two. Okay. Now some people are going to distribute the 1/2 here, and there's nothing wrong with that. But for me, I think it's easier to just double the whole equation. Okay, so I'm going to multiply the whole equation by 2, because when I do 2 times 1/2, that's just 1. And then so this right side is going to simplify to just y plus 80 degrees, because if you take y plus 80 degrees, divide it in half, and then multiply by 2, you just end up at y plus 80 degrees. Okay, and then over here I'm doubling 86, so I'm going to get let's see, 116, 12, 172 degrees. Okay, and now I just have to subtract 80 from both sides, and y equals 92 degrees. Okay, all right, so let's move on to the next scenario then. Okay, like the bottom of that up there. All right. So next, we're going to look at some scenarios where the lines don't meet inside the circles like they did in the previous problems. Okay, so you can see our lines are meeting outside the circle in all of these. That's why I call this the angles outside the circle theorem. Okay, so in each one of these problems, I'm going to mark the angle x. So this is going to be x in all three of these. Okay. I forgot. Let's read the theorem. Okay, when two lines, tangents are secants. So tangents are lines that intersect the circle once, like these two, and then secants pass through a circle twice, like these two lines. Or you could have a combo of each. So when we have tangents and secants that meet outside a circle, the angle that they form is equal to, it's going to be equal to 1/2. It's the average, sort of, but it's not really the average because we're subtracting instead of adding like we were before. Okay, so I'm just going to write this. It's equal to 1/2 of the bigger arc, the bigger intercepted arc, I should really say, minus the smaller one. Just say the smaller arc there, but it's the smaller intercepted arc. Okay. So yeah, let me talk about what that means. We're going to use this to solve for the angle here, or sometimes for the arcs that they intercept. All right. So x intercepts two different arcs. It intercepts this arc that I have marked blue there, but also this one that's orange. Okay. So I'm going to call the blue arc y and the bigger arc z. Okay? And same thing's going to happen with the other two scenarios. I've got the first arc that it intercepts, I'll call y, and the second one can be z. Okay? And in all of these scenarios, I need to differentiate between the big arc and the small one. Well, since these angles are opening and getting wider and wider and wider, that means the arc that's farther away is always going to be the bigger arc. So in all three of these, z is the bigger arc and y is the smaller one. You can tell just by looking at it, but the smaller arc's always going to be closer to the angle that's formed. Okay? So just to make this generic, I can say that x, that's the angle that's formed, right, is going to be equal to half of the big arc minus the small one in all three of these scenarios. That's z minus y. Okay, so it's very similar math to what we were doing in the previous problems, except before we were adding the two arcs together. Now we're going to be subtracting them. Okay, and if you try to do the smaller one minus the larger one, you're going to end up with a negative number. And we're not going to have negative angles for these problems. So you'll know you subtracted the wrong way if you get a negative answer. Okay. All right. So let's try some examples. Try to leave that formula up here. Okay. So I'll put an x right here. 76 degrees is going to be the measure of this arc. And then this one can be 178 degrees. Okay. All right, so let's solve for x. Split this in two here. Okay, so these meet outside these lines. So x is going to be equal to 1/2 of the big arc minus the small one. So x is going to equal 1/2 of 178 degrees minus 76 degrees. Okay, so again, you could distribute, but I wouldn't do that. I would just do the subtraction in here. So 178 minus 76 is 102. So then I just need half of 102 degrees, and that's going to be 51 degrees. Okay. All right, I'm going to give you one to try. So this time I'm going to put 30 degrees right here. This arc can be 44 degrees. And then X is going to be this arc. Okay, so once you give that one a shot, remember the angle is going to be equal to 1/2 of the big arc minus the small arc. Okay, all right, go ahead and pause it. I'm going to work through it now. So the angle is equal to 1/2 of the big arc minus the small one. Okay, now you could distribute here if you like. I just like to double the equation. It's just a little less to deal with, and I don't have to deal with any fractions, because 2 times 1/2 is just 1. So then 60 degrees is going to equal X minus 44 degrees. And I just add 44 to both sides, and I get 104 degrees. Okay. Okay, so moving on, one last type of problem I want to show you. Also, one thing to watch out for, just some advice, if you get stuck on these problems on the homework, check to see if there's a diameter. Sometimes there's a diameter in the picture, and that tells you you've got, if this were a diameter, then I'd have 180 and 180. So sometimes that can open some new doors for you if you feel like you don't have enough info. Okay, so moving on, here's our last scenario. We're going to solve for X. Given info here, this is going to be X, and this can be 124 degrees in here. Okay, and this is a central angle. I know that because that is marked with a dot there. So it not only looks like the center, but it's supposed to be the center. Okay, so there's a couple of ways you can approach this. There's a little shortcut that I can show you, but first I want to explain why this is going to work. Okay, so if I'm looking at this angle, I've got the two arcs. Here's my small arc, which is not marked, and then my big arc, which is not marked either. Okay, so this is a little tricky to begin with because, or it's at least different than the other ones. The arcs aren't marked. But wait a second, I've got a central angle. Okay, so let's forget about this stuff for a second. If I've got a central angle here, some people are going to put 248 degrees because they doubled it, but central angles, the measure of the central angle is exactly the same as the measure of the intercepted arc. So that arc is going to be 124, okay? Now I still need to come up with something for the bigger arc. It's still not marked. But here's the thing. The whole circle is 360 degrees. So I can figure out what this blue arc is because it's going to be the whole circle minus the little arc, right? The two arcs together give you the whole circle. So this is going to come out to 236 degrees, okay? So now I have what I need to solve the problem. All right, so I can say X equals 1/2 of the big arc minus the small one. Angle equals 1/2 of the big arc minus the small one. And I'm off screen. Okay, so that's going to be 1/2 of 112 degrees, which is 56 degrees. Okay, I'm going to show you an alternate way to do this. So another way you could have approached this, these are both tangent lines, right? The lines on top and bottom. And this is a radius of the circle that attaches from the center to the point of tangency. So if you remember back to the beginning of the chapter, that means got a right angle right there, right? Same thing right here. I've got a radius that attaches to a point of tangency. So I've got right angles in both of those places. And now what you could do is take this quadrilateral, okay? So I know what the measure of those are going to add up to. You can do n minus 2 times 180 if you go back a couple of chapters, okay? But they're all going to add up to 360 degrees. But the thing is, 180 degrees is already spoken for, right? So, you know, I could say, they all add up to 360, and that's fine. I could solve that. But I could also say, well, instead of all of them adding up to 360, 180 degrees is already spoken for. So that means that these two are going to add up to 180 degrees. Okay, so they're supplementary, right? And then I can just subtract and get 56 degrees, okay? Now I wouldn't, since I've done this a few times, I would just look at this scenario when you have a quadrilateral like that, where you've got tangent lines and one of the corners is in the, the center of the circle. These two angles are just always going to be supplementary, okay? I do want you to understand why they're supplementary, but you could just, if you just remember they're supplementary, solve it like that, okay? So why don't you try one over here? Let's see, I'll have this be, okay. All right, go ahead and pause it, try it out. So honestly, the way I do it, right away, I'd say, oh, this is my scenario like over here, so these are going to be supplementary. Okay, but we can also think through it using the intercepted arcs. So I could say that this arc is going to be x, okay? And then the bigger arc, I don't know the measure of it, but I know the two arcs together form 360 degrees, so I can call this 360 minus x, okay? And now, it should really be degrees. Okay, so now I can use the formula. The angle is going to equal 1/2 of the big arc. The big arc here would be 360 minus x, minus the small arc. The small arc is x. Okay, so if I simplify this, I've got negative x minus x. That's going to be negative 2x. So 70 degrees is going to equal 1/2 of 360 degrees minus 2x. Okay, you could distribute, which would actually work out pretty nicely. You won't have any fractions here, but I'm going to just double the whole equation. Okay, I'm going to subtract 360 from both sides. And then divide by negative 2. And then x is going to equal 110. Oh, whoops, sorry, I was off screen there. And x equals 110 degrees. So nothing wrong with that. It's just I can take a really quick shortcut if you just remember those two angles would be supplementary because the other two are 90 degrees. Okay, that's all I got today.